In a surprising and paradigm-shifting development, scientists at the Universidad CU San Pablo in Spain have identified a microscopic parasite, long regarded solely as a health threat, as a potential ally in the fight against aging and certain forms of cancer. The research, led by Carmen del Aguila and her team at the Perrin Research Group, specializing in parasitology and molecular immunology, focuses on a microorganism known as Encephalatozoan cuniculi, a type of microsporidia. While these organisms have traditionally been associated with infections in immunocompromised individuals, new data suggests that under controlled circumstances, their interactions with host cells could offer surprising therapeutic benefits. At the heart of this breakthrough lies the discovery that cuniculi can influence cellular aging processes and immune signaling in profoundly beneficial ways. Rather than simply being a pathogenic invader, this intracellular parasite appears capable of reducing inflammation, modulating longevity-related metabolic pathways, and even enhancing the body's own anti-tumor immune responses. One of the most striking findings is its ability to downregulate the production of interleukin-11, IL-11, a molecule associated with chronic inflammation and tissue damage. By doing so, the parasite may slow down harmful aging processes at the cellular level, something that could pave the way for new therapeutic strategies aimed at promoting a healthier, more resilient aging process. Even more promising is the parasite's effect on the PD-L1 protein, a critical component in modern cancer immunotherapy. Normally, PD-L1 is expressed on the surface of some tumors, allowing the immune system to recognize and attack them when therapies like checkpoint inhibitors are used. The researchers found that cuniculi infection can actually induce the expression of PD-L1 in cells that otherwise wouldn't present it. This opens the door to the possibility of enhancing the effectiveness of immunotherapies in cancers where PD-L1 is absent or insufficiently expressed. Instead of blocking PD-L1, as is common in current treatments, this new approach would use the parasite's influence to turn on PD-L1 expression selectively, making tumors more visible and vulnerable to immune attack. This fascinating twist not only enriches the scientific narrative around aging and immunity, but also emphasizes a powerful truth in biology. What is harmful in one context may be healing in another. The study suggests that nature's complexity often holds the key to its own solutions. A microorganism once regarded solely as a parasite, dangerous and damaging, now appears to have tools that, if correctly harnessed, could contribute to preventing or delaying aging-related decline and to making cancer therapies more broadly effective. Of course, these findings come with necessary caution. The researchers are fully aware of the potential risks. Cuniculi has been detected at significantly higher rates in colon cancer tissue, up to 20 times more often than in healthy tissue, raising concerns about its dual nature. While it may support immune functions and reduce some aging markers, it could also, under different conditions, contribute to cancer progression. This paradox reflects the need for precision. We must learn to use the parasite's capabilities without unleashing its pathogenic aspects. Nonetheless, what's being proposed is nothing short of revolutionary. Instead of fighting against such microorganisms with blanket suppression, future medicine might involve strategic collaboration with them. The research team is now planning animal model studies to further investigate how cuniculi interacts with host cells, especially which proteins are responsible for its beneficial effects. A future goal is to isolate these proteins or mimic their action through biotechnological means, potentially eliminating the need to use the live parasite altogether. If successful, this line of research could lead to the development of entirely new classes of treatments: anti-aging therapies that are immunologically active, cancer drugs that train tumors to reveal themselves, and a better understanding of how our immune system can be influenced, not just suppressed or boosted, but guided, refined, through natural symbiosis. This study is a powerful reminder that the line between pathogen and partner is not always clear. In the microscopic world, complexity reigns, and life has evolved in ways that often defy our expectations. If properly understood and controlled, even a tiny parasite can become a partner in health, extending not just lifespan, but the quality of life itself. Would you like a follow-up that explores other microbes being studied for anti-aging or immune-modulating properties?